Uh, we have a little bit of delay, so sorry for initial hiccup in all the setup. The story that I would like to tell you is named Map of the Future. Map of the Future, why? Because TomTom, so what we do for business, for living, is nothing more than everything that is connected with location. We are in business already for about 30 years, and we have been pretty successful in it. And that's why we can actually tell how that entire business was looking like before, and how the business is going to look like in the future. My name is Marcin Kmiecik, and today I have been working for TomTom for about 17 years now. And today I play a role of being CTO of Maps. And we have pretty neat and very powerful division that is processing the data that gets to your device whenever you need it. So, a little bit of the history, because we cannot tell anything about the future if we don't know the past. So imagine the world we are in the in about 300, 400 years ago. Imagine how mapping was looking like. So imagine that you are Magellan, for example, one of the greatest explorers in the world. What you would do, you would want to understand and explore the world, right? So you are getting onto the ship and you plan your mission. You go there, you go out there, you have a little bit of the knowledge, what is expected there, but not so much, right? And you do your trip, you go all the way, and you come back, and you are very successful, right? So you come, you go, you go from Spain, you cross the entire world, you go back, and you tell the world. But what you are doing on the way, if you are Magellan, you actually, in the beginning, you come to the Queen of Spain and you pick up the most accurate map that was there in these days, right? It was pretty crappy, but this was the most accurate map that you wanted to have. And you take that map, you take it with you, and during the trip, you actually during your navigation, you actually also measure the coastlines. You go, you measure the coastlines, you try to make something for yourself, but also you store it on the ship. Right? It takes you 3 years. You come back, and what you do is you get what you mapped and measured, you come back to the Queen and give that data to the Queen. Give that data back to the castle. That's how the past explorers were actually mapping the world, right? So that was a single trip that was dedicated for something that went out there with very limited knowledge and mapped it, stored it, and integrated it back with the main map of the kingdom. And why is it important? Because I wanted to show you a couple of numbers, because this shows you the evolution. Once we're going to understand the evolution, how it all went, we're going to understand how the evolution is going to progress. So Mr. Magellan had a cycle of going out and coming back of around 3 years. Imagine that. And it was a very small trip. If you look at if you go to the internet and you would find the image of his route, you would understand that it was a very single trip that was able to map very limited set of coastline. That was very partial information. And that partial information was delivered back to the castle, to the Queen of Spain, and it was integrated with all other explorers that were there in the world. And that's how map was created, how map of the world was created. To get to the semi-accurate map of the world, it took the entire humanity about 300 years. It's pretty impressive. It's more than our life, right? So all those explorers were there just to update a very single piece of the map, very small. Nothing that was, and there was no device that could map the entire world at once. And I'll tell you more, there is no device, even today, that can map entire world at once. So from that perspective, nothing really changes. But this cycle is very important. So you have something that is a common knowledge of humanity. You take partial knowledge about it, because you don't have to, on your trip, you don't have to take entire knowledge. But you could. You go there, you actually start to measure the next things, you complete the knowledge, you come back, and that knowledge is reintegrated back to the main map. Before I go to the today, you all are IT guys, so you can imagine what happens in that 3-year cycle before Magellan comes back. What happens? You have more explorers that also come back. And guess what? Their data might not be measured the same way. The data might be in conflict with each other, right? Because if you measure something, if you look at the sun, your accuracy is like, I don't know, maybe 10 kilometers, 1 kilometer those days at best. So the data that comes back starts to get in conflict, and that's why you need to have a very heavy integration process in the end that makes it back to the common knowledge of the map. So that's how the world was looking in the past. About 30 years ago, TomTom invented digital mapping. And this is basically repeating, because there's no, as I said, today there's no device that can map entire world. It is roughly repeating the same pattern. You go, you have some source, you have a map-making platform, you release a map, and that map goes to the device. And then on the device, you have a trip. Right? There is a small difference that you see here. You see here that there is no loop. Right? 30 years ago, we have been delivering the data to the device, to the car, to the aftermarket device via some kind of a synchronization processes at best, but typical delivery to your car was with DVDs or CDs or even tapes in the past. Right? So you see that we introduced the digital mapping 30 years ago, but we kind of broken the pattern. We had different sourcing mechanisms that were completely outside of the loop, and that created that was pretty heavy. In those days, we had to rely, and we still have to rely, on multiple sources. So those sources that come from outside, these are not coming back from the trip, right? And it was not happening before. So between 30 years ago and now, TomTom has been developing a lot of technology that were related to the map sourcing. And this is the example. You see that example of the technology that we call mobile mapping. We have invented it in 2001, and we have been pretty successful in it. This is one of the most accurate sources in the world of making a map. And we collect with multiple vehicles. We still collect a lot of data that is spanning across the entire globe. And the vehicle consists of image data. It used to be in the beginning, right? Obviously connected with the GPS position. Recently, about 5 to 6 years ago, we introduced LiDAR, which creates in your neighborhood. It creates entire point cloud. So while the vehicle moves, it maps and creates a point cloud of the neighborhood. And the numbers behind those collections are pretty neat, because today our database, our global database of such source, is consisting of about 10 petabytes of data. So you can imagine right now a little bit, you can feel it, you can feel the complexity that we have to deal with. But this is just a single source. As I said, there is no single device in the world that can map entire world, and that pattern still is correct. So this is one of our sources, and it is 10 petabytes. Highly accurate, runs every hour across the world. We have dedicated collections to it. So this is what we had to invent. If we broke the loop, right, we had to create mapping sources that were completely coming outside of the system. The second thing is, like you had with Magellan, somebody was picking up the map, and that map was on your device. Today, the same map is also on your devices. So what we have developed over the last 30 years is an entire network of partners, including our own devices, of course. But we do more than just our devices. So the fact that you see a TomTom device, there is a map, but TomTom map is present in a lot of more devices. In fact, we estimate that our reach to the global world is about 1 billion people. So our maps cover, are used today and are experienced for about 1 billion people. One of the things that you can experiment, even on that session, if you go to Apple Maps, click on information, and you will understand on your iPhone, you will understand that the map comes from TomTom, actually. So, and you kind of see the pattern. This is the same story. The same story repeats. We have a global repository. We deliver it to billions of devices today. You guys do your trips. We are still back in the past, so I'm not going to disclose what happens next. But this is how, and we do, and we source the data. That data is source data is pretty difficult to understand, pretty difficult to process. So those days when we introduced digital mapping, this is how the sequence was looking. There was some external source where we did measurements. We still have been doing manual labeling. So all the data that was coming in was actually processed by people manually 30 years ago, 20 years ago. We have been integrating it, and we have been integrating it in the way that we created a map every quarter. That was pretty amazing thing that we achieved. Because if you think about the history, we have been able right now to deliver a fresh map every 3 months. We are still back in the time, right? Nothing impressive today. And we actually shortened also the cycle to map the entire world. But was it the answer? Probably you know it, right? That today it's not an answer. So once again, TomTom about 8-9 years ago made a next revolution in the map making. So what we did is that we actually closed the loop. The data is right now coming both from external sources to the map, but also you kind of, whenever you use the map, you start to be a little Magellan. Whenever you want to share the data, you share it with us, right? There is typically we ask a question if you want to share the data, we ask you about it, and that data comes back to us from 1 billion people all over the world. And that created a big opportunity, right? Once again, we are about 10 years ago. In the beginning, of course, we had this system set up in our own devices only, right? So only about 50 million users. Right now, thanks to our partners that I showed you in the other picture, we are collecting the data from about 1 billion people all over the world. So every time that you drive, every time that you make a trip, every time that you are out, you actually make a Magellan trip. You measure, it goes back to our system, and we try to understand what actually changed on the map. Because if you think about it, the map, typical map, the problem of the map is that you can do it once, you can do it second time, but you will never be up to date, right? If you do it just by yourself, you will never be up to date. And this creates a big issue for the end user. I don't know how many people are using navigation systems, but I'm sure you experience errors in the map. What kind of system there is in the world, that problem is still not solved. The map, whether you go to us or whether you go to our competition, such as Google, you will see that there are errors. You will plan your trip, and you will see about, I don't know, 5% of errors of your trip. You go, and then you are annoyed. Well, there was a prohibited turn, and I had to turn. The device told me to go somewhere. So that's actually an essence of our business. The essence is to make sure that our users have accurate information. But the problem is that accurate information is not static. It changes every day. And this is what our backend system is actually solving. So since we introduced the digital maps, we try to reduce that cycle. And that actually is going to be one of the key points of the future. So going back to your mini Magellans. So if you can imagine those 1 billion people traveling all over the world every day, commuting to home, commuting to work, going to vacations, you see that if you count it all up, you see one number. And this is the number that is extremely important. Today, all those little Magellans are traveling the world, if you just compute the distance traveled, all over the world every 1.6 seconds. So 300 years ago, it was 3-year trip. That much data was collected. Of course, there were multiple explorers, so probably the 3-year would be a little bit not fair to them. But today we do it every 1.6 seconds. It's both, once again, opportunity as well as problem, because you had to compute it. We are using today about 900 machines to do it. The storage to collect all those little traces, all those paths from your trips, is about 400 terabytes. So that's the scale that we deal. And that creates another challenge, because the model of like 30 years ago doesn't stand anymore. So manual editing of the map doesn't catch up with all those changes, that's for sure. And that's why you have to do map fusion. So you have all those sources, you have all those traces, you have 10 petabytes of image data, you have terabytes of trace data, you have governmental sources, and you have to pull it together, because why? Because there is no source in the world that is accurate. So even if you make a trip, GPS, if you and I think you can actually see it downstairs on our booth, the GPS itself can make magic. It can be off by several hundred meters. So what you have to do is you have to extract from that meaningful information for all those 10 petabytes of data, from all that point cloud, from all that image, to create a perfect accuracy map, right? Or as much perfect as you can get with the input. So what you do there? Obviously, you take all that you hear today. You take all the techniques that you hear today. You take image recognition, deep learning. You have thousands of machines. So all the scalability that you hear today about in the technical sessions, that's what we actually actively apply. There is no silver bullet. You cannot, take one fantastic deep learning machine and apply it to the map. At least not today. So we use combination of techniques. We use combination of state of art, as well as scalability. And the pattern that you see, that every technology is repeating, is that you go from source, you start to observe it, right? So you try to extract the meaning of the information, you try to extract the science from the images, you try to extract, let's say, deviations from the map, from the GPS traces. You create from those something that is called an evidence, and then using some confidence model, Bayesian techniques, you pull it all together to one map. And of course, the technology of today is still not ready for 100% automation. What we achieved with all that variety of sources, we are still trying to understand how the next scalability and how the next technologies are going to help us. I actually invite you to the next session that one of our AI guys is having about machine learning applied to the map. He's gonna deep dive into that part on today. And then you create typically the transactions. So you close the loop. There is massive amount of sources. You create your database transactions, and you achieved 80% of automation. That's how the system is working. The second thing that such large system has to do is that it really have to conform to all transactionality paradigms. So imagine all those billions of traces, all those billions of potential changes that are fused into one system. To really integrate it to the map, you have to create your database of the map that is fully transactional. Why is that? Because the user will not forgive you any mistake in the map. So typically, if you detected that there was a crossing and it suddenly has changed to the roundabout, you cannot break connections, because that is the disaster for the end user. So you have to create that roundabout in one single transaction and commit it at once. The ugly nature of our data is that the context of such transaction is typically 100 times bigger than the transaction itself. So what you have to process is that you change, let's say, I don't know, typically we change about 1 megabyte. So you have to pull, in one transaction, you have to pull around 100 megabytes of data to actually commit that, to check it, to check if this is consistent with the rest of the world. Because the entire world will not forgive you if you're gonna break the connections. The world is nothing more than a living graph, a big gigantic database, and the world will not forgive you if you just for a single moment will start to break those connections, because people will lose the travel, they will get annoyed with the experience, and it will actually make it worse. It could make it worse. So you have to be very careful when applying those transactions. And once again, those days we have been a little bit ahead against well-known technology. And because the database, as I said, is quite nice, quite big, is about 500 terabytes, consisting of about 100 databases that are sharded. But we had to make it ACID. And there was no technology. Even today, if we experiment with existing Google technologies or other technologies, it's not ready for our use case. We had to make it for our use case specifically, that it became ACID because of the spatial nature. The spatial nature of the database is one of the most difficult topics in the world to process with, to deal with. And there is no single, today, they are getting there, but today there is no single technology that can handle our data in the ACID way. They are getting there. They're going to be there soon. And this is not only about the size. The main problem is about how much you have to handle. So because of the fact that the transaction has 100 times bigger context than the transaction commit itself, you actually have to process a lot of data on the bloody database. You have to pull about 100 gigabits per second and write about 500 gigabytes per day in order to achieve the volume of changes that are coming to the map. And this is not the end of the story. Our users, so once again, the today word, you are not really happy yet with the experience of the navigation. We are getting there, but you are not happy. And the third paradigm that we had to invent was incremental delivery. So if you have in mind the size of the database, of course, on your device is a little bit more compressed. It goes is not 500 gigabytes, but it's more compressed. So what you have to deal with is you have billions of devices to update. So imagine if you're going to compute the number of bytes that we produce a day and try to stream it to all devices in the world. If you do it as previously, like on the DVD delivery, and transmit the entire map to the device, internet would break. Internet doesn't have such capacity to transfer entire map to 1 billion devices with the frequency that we produce it. So once again, we kind of created the problem by ourselves where we have to solve it. So what happens in our systems is that we do incremental updates just because of that. So if you think about how many changes are happening as we speak in the map, in the world, imagine 7 billion people out there, each of them building something, each of them opening new businesses, each of them dealing with the with day-to-day world. They create about 10 versions per second. So globally, is about 10 versions per second. So, and all of that has to be streamed to billion devices, or even more in the future. So it has to go incrementally. Even if you are online connected, typically your device has a cache, right? So it would also complete that cache. And that's the reason why there is no something like complete cache replacement, although some of the old school technologies do it that way. Like if you go to Google Maps, you would up the entire cache. And that, I hope that Google will solve it. We solved that. And all our increments go to your devices. All our maps go to your devices incrementally. The second thing is that those increments goes in a targeted way, because even if I would stream all the changes to your device constantly, it would once again, internet would not survive that. So today, where we are today, in all that cycle, so we can try to understand what is going to happen in the future. So we have the loop that is closed, right? So we finally are where our explorers were in back 400, 300 years ago. Every time you go to the trip, you actually contribute to the map. You create huge volume of the data. We have to deal with it with using different technologies. Once again, next session is going to be about what particular technologies do we use for that. And we changed a couple of things compared to where we were. We have transactional integration, right? We have incremental delivery, and we have about 80% of auto-labeling, automated labeling of the map, and we take measurements directly from your devices. That enables us to reduce the cycle even further. So we have right now the cycle of 3 days, and we are capable to deal with all that volume of the data. So now that you heard that story, what we're gonna try to understand how the map is going to work in the future. So how that cycle is going to complete, knowing that all that information. So first of all, let's step back a little bit, because that cycle that I told you about typically is about one of the information layers in the maps. The map is something more than just road network. The map is consisting of multiple sets of informations, and all of them have different frequency of changing, of course, right? So you have your basic infrastructure layer, which in our case would be the routing layer. Then you have addressing. Then you have other attribution for navigation, like turn restrictions. You have your POIs. You want to go to the restaurant. You want to visit some hotel. All of that has to be in your map, because otherwise you cannot plan it, right? Everything, it has to be in your map. And then the information, richness of information is increasing more and more, higher and higher, better accuracy, better positioning, and you go all the way. Today, we already support advanced driving assistance systems. So, for example, if you travel with your vehicle that has ADAS capabilities, you would see there speed limit changes or dangerous curves that comes actually from our measurements. One of the best maps in the world for when it comes to ADAS is coming from TomTom. So we found it that type of the map is actually very beneficial also for trucks, where they want to understand their fuel consumptions, which typically is a function of the slope of the road, so how the road is going up and down. That information has to be extremely precise in order to steer automatic gear control. So this is where we are. And we are building a future as we speak as well. You're going to learn about it on the next session. We create something that we call HD maps, which are extremely precise. They are 10 centimeters accurate. So every part of the road is about 10 centimeters accurate. And they are meant to support automated driving. But we wouldn't be there. We wouldn't be there if we wouldn't master that cycle. Why? Because even if you have accuracy of 10 centimeters, your map, once again, is constantly changing. So even if you are very high when it comes to precision and accuracy in space, then you have to deal with the time. Because imagine the automated autonomous vehicle that has inside an outdated map. Typically, it would cause a failure in the system, meaning pretty serious accidents. So all those vehicles not only have to receive the information that is accurate in space, but is also accurate in time. And more, the higher accuracy you achieve, the better you can go with your in your map usage. So you have your strategic usage, you have your tactical usage, you have your operational usage, and then, so this is something that happens today. We have road planning, we have navigation, we have real-time traffic. All those layers enable you to deal with it. And then something that will be in the future, the map will be actually augmented in your everyday life. So if you're going to make yourself a coffee in the morning, you will already have a planned route, and you will know when you're going to achieve your destination at work. So this is how this future is going to look like. And in order to get there, what you have to do is you have to actually map it all. If you want to have the map that is actually not a map anymore, or this is real representation of the real things that are happening, you not only will map the infrastructure, you will not only map the other layers that I'm talking about, you will map everything. So what will be happening? What will be happening in that cycle? Something that is very obvious. You probably learn it from everyone. Obviously, once we attach the device to the chip, and once we start to feed that information, those devices can collect more and more. They will start to collect images. They will start to collect other data. What we're going to experience is we're going to continue our journey with the exponential data growth. That's what is going to happen. The data will not stop growing, or at least the data that is that those devices can produce will not stop growing. And you're going to see bigger and bigger demand for freshness and quality, right? So the precision, accuracy in time and space that will not stop here. We'll have to go to about I don't know, 1 minute, 10 centimeter map, something like that in the future, of entire globe. So you can extrapolate it. Today we do it with so much data, 10 petabytes, and we achieve only, I don't know, that we update every week, right? So, and you need to go to a couple of minutes. So you can extrapolate the data that is going to go through our systems. And that all will also stimulate the data benefits of data sharing. Because if you have so much data and you have to deal with it, do you imagine today's world where everybody stores their own databases and keeps it home, tries to protect the data? This will be broken. This paradigm will change in the future. Why? Because of the data size growth. The world will not be able to handle the data if we would keep the data on premise clouds, on premise infrastructures. So what? Something that is very obvious once again. We will have to continue our journey on the machine learning and artificial intelligence. But the way, if you compare the way the industry is doing machine learning today, it will once again have to change. Why? Because today you have many companies are doing very isolated experiments with the data. You saw it on the previous session. You have set that is fixed. You try to infer from it. But the map and the world around us is constantly changes. So what will have to happen is you will have to automate the automation. You will have to understand what really makes machine learning an industrial thing. Because today you just have techniques. I typically compare it with about 20 years ago, how we used to code. We didn't have central repositories, we didn't have Gits, we didn't have quality checks, and the same today is happening with machine learning. You don't have really systems to deal with machine learning in an industrial manner. And what will have to happen in order to get to the future, we will see the systems like Git, like tests of the code that are embedded in your life cycle of producing artificial intelligence. It will no longer be in isolation done by data scientists. It will not be in the isolation done by researchers. It will be something that is industrial, another scale of artificial intelligence. Because you will have to develop on the fly new patterns, test them, and deliver in that 1 minute cycle. So train the machine every 1 minute. Train artificial intelligence every 1 minute because it's something new. There is new pattern in the data that can be discovered. So that's another problem that going to 1 minute map is something that we forecast. Is if you think about all the data, all those devices transmitting the data while you go, the meaningful information starts to be more and more fractional. So the fact that you have driven a certain road and there is another car passing by exactly the same road in let's say in 10 minutes might not be an information gain. Right? There are all theories about information gains in statistics. So a lot of the data is not actually causing any information gain. And we will have to deal with it. Because everybody is like kind of a Facebook, right? If you think about it, all the data that is going through is kind of Facebook of digital mapping. It goes all the way, but there is a little really beneficial information in it. So what will have to happen is that we will have to deal with it with incremental processing, like we did with transactionality, all the way. So your artificial intelligence will have to be incremental. Your device, your intelligence in the device will have to also be adapted because it cannot send just everything from exactly the same reason. So once again, you will see a lot of data that is simply not usable to the consumer of the data. And that's why something will happen in the future that probably will push that intelligence back to the device. So some of the AI will be in the devices, and then the way we're gonna deal with it is probably we're gonna sample. We're gonna test the devices. Do you have meaningful information? Do you have meaningful information? Yes, you did. No, you didn't. So the device will learn what actually can it send and what should it send. It's not going to be a passive thing like today. It's going to be active part of the ecosystem, active part of the map. Last but not least, I told you only about one single loop, which was an example of the loop in the typical vehicle navigation systems. But what you're going to see in the future, and we see it happening in different data ecosystems, is that people out there are also developing those loops. They also have to measure infrastructure. Governments have to measure infrastructure. Your Roomba in the home, your Roomba device, your vacuum cleaner, will be mapping your home, and it will updating it, right, as well. If you're gonna walk in the park, if you're gonna do something for your living, you also will participate in kind of a loop as well. Like if you cycle, you're gonna create information about cycle maps. So you see, in the future, you will see many loops like that, like little Magellans, and that information will be shared between those ecosystems. Why is that? Because, for example, you typically today know that something happened on the map. So you drive, you have the information about traffic. There is a closed road. But the problem statement is that we detected, us or our competition, we detected after the fact. So somebody closed the road, and we detected via a couple of Magellans. But we don't have to. Somebody has planned to close the road. A government, right? A government has planned to close the road. But the problem is that it has no information system to come back to us. So what I feel we're gonna do in the future, we're gonna connect all those systems, and the government will close the road, and then it will be automatically happening in the map. So you will know, once you wake up in your morning coffee, you will know exactly that your road will be a little bit delayed. And this is exactly how the future of map making is going to look like, how map of the future is looking like. So it's not anymore something that is static. Today it's already not static, but it will be even more dynamic, and the map will consist of multiple ecosystems that are connected together, and artificial intelligence is going to play even bigger role than today, right? Today we are pretty advanced in processing the data with artificial intelligence, but this is just an iceberg what is going to happen. And going back to my slide about strategic, tactical, and augmented, only once we get there, we can enable other use cases. So then we can enable autonomous driving, then we can enable smarter cities, and then we can enable predictive planning. Because tomorrow, the map is not only accurate about what's happening today, but the map is accurate also about what is going to happen in the future. And with that, I leave you with that story. As I hope you're going to join the next session, which is going to deep dive a little bit into how we use artificial intelligence for HD mapping. And of course, as everyone, because we are developing artificial intelligence, we are dealing with a quite complex problem. We invite you also to join us. It's pretty neat experience to deal with maps. Thank you.